Okay, so question 1, here we are to sketch the graph of y equals mod 4 cos 2x between 0 and pi. We've got to give the coordinates where the graph meets the axes. Okay, before we start this, I think it's helpful just to recap how we sketch trigonometric graphs in general. So we're going to start with y equals a times by cos bx plus c. Okay, now each of those letters A, B, and C means something. So start with A. A is the amplitude of the wave. That is how far from the center line to the peak or from the center line down to the trough. B is the number of waves in 360 degrees or in 2 pi radians. Now that's going to be related therefore to the time period, which is 2 pi divided by t, divided by b, or if you're dealing with degrees, 360 divided by b. And lastly, c. C is like the shift in the y direction. And that's going to tell you the position of the center line. Okay, now if that's not entirely clear, I've done another video going through that in a bit more detail. But in essence, what's being described is this. Okay, let's draw a quick cosine graph. We'll go in the opposite order, C, B, A, okay? So C tells you the shift in Y, which means it's going to tell you the center line. So this here would be coordinate C. Okay, the wave, if it's a cosine, look like that. Okay, and that is one full wave. So that would be the time period there, right? Because that's how long it takes for us to complete a wave, and therefore we can calculate B using this formula here. And then the amplitude is going to be this distance here, either from the center line to the peak or also from the center line to the trough. Okay, so that would be the amplitude. Okay, so that's the way we can understand the trigonometric graph. So let's go back up here. First point is, in this particular graph, our C is going to be 0, so the center line is going to be the x-axis. Here, our B is 2. Okay, now if our B is 2, then that means we should be able to calculate the period. The period will be 2 pi divided by 2, which will be equal to pi. So in other words, we expect that one complete wave is going to take pi radians. Lastly, we know that A, our amplitude, is 4. So we're going to have a peak at 4 and a trough at -4. Okay, so if we were to label this, I don't know what the best way to do that is. 1, 2, 3, 4. Let's label that as 4. And let's label this as -4. Okay, and we're saying we're going to have one full wave between 0 all the way up to pi, right? Because that's one period of the wave. Now we also know that a sine wave or a cosine wave is divided up into 4 equal parts. So we can split up this wave, this point, this point, and this point. Okay, so firstly the wave is going to go down through to the center line. Sorry, it's a bit rough drawing. And then from the center line down to the trough, and then from the trough back up to the center line like that. Oh, it's not very good. Try that again. Okay, and then from the center line all the way back up to the peak. Okay, now then, these coordinates here will be pi by 4, pi by 2, and 3 pi by 4, because these are quarters of pi, right? 1 quarter, 2 quarters, 3 quarters. However, the last thing we've got to do is notice that we're dealing with a modulus graph here. Now, when we've got a modulus, what happens is everything inside the modulus that is negative becomes positive, and everything that's positive remains unchanged. So we've got to look at where the graph is negative, and the graph is negative here, right? So what's going to happen to that is it's going to be reflected in the x-axis. So I'm going to take this thing here, and I am going to delete this little part of the graph. And I'm going to redraw it, but reflected. Okay, up to there, and down to there. Okay, guys, so that is question 1. Okay, question 2, which is a surds question. We are supposed to expand and simplify this expression here, giving our answer with a rational denominator. We are not supposed to use a calculator, which means we've got to demonstrate all of our working very clearly. Okay, well, let's write it out. We've got x times by the square root of 11 all over 2 root 3 minus 1. And if we're squaring this, it may be helpful for some of you just to rewrite it again. So x times by root 11 over 2 root 3 minus 1. Okay, well, let's expand the numerator. So we're going to do x root 11 times by x root 11. Well, x times by x is going to give us x squared. And root 11 times by root 11 is going to give us 11. Okay, because it's the same thing as the square root of 11 squared. Okay, let's do the denominator, I think. So we're going to have 2 root 3 times by 2 root 3. Well, that's the same thing as 2 times by 2, which is 4. And then root 3 times by root 3, which is 3. So this is the same thing as 4 times by 3. Okay, after that, what we're going to have is 2 root 3 times by negative 1, which is minus 2 root 3. But of course, we're going to have that again because we've got negative 1 times by 2 root 3 again. So we've got another minus 2 root 3. Let me just expand that a bit. And then we're going to have negative 1 times by negative 1, which is positive 1. Okay, well, we probably want to simplify that denominator a little bit. So we'll first write 11x squared all over. We're going to have 4 times by 3, which is 12, plus 1, which is 13. We've got minus 2 root 3 minus another 2 root 3, which is minus 4 root 3. Okay, well, that doesn't look like it will simplify. So what we've got to do now is we've got to rationalize our denominator. And the way we rationalize our denominator is we multiply the top and bottom by the conjugate. And the conjugate is 13 plus 4 root 3. In other words, if you've got an expression a plus b on the denominator, you need to multiply everything through by a minus b. And vice versa, if you've got a minus b, you've got to times by a plus b. Okay, so on top and bottom, we are multiplying by 13 plus 4 root 3. Can I just also mention here, you really should put brackets here, right? If you're not putting brackets, actually what you are writing is wrong. And I think it's important that you are communicating all the time to the examiner that you know what you're doing. Also, this will guard you against making a mistake, right? Otherwise, sometimes students say this is 4 root 3 times by this thing, and they forget about the 13. So you want to avoid making that kind of error. All right, let's expand this. So on the top, what we're going to get is we're going to get 11x squared bracket 13 plus 4 root 3. And then on the denominator, what we're going to have is 13 times by 13. So that's 13 squared. Just double check my arithmetic just to make sure. That's 169. And then we are going to have 13 times by 4 root 3. Okay, so that's going to give us plus 52 root 3. But also we're going to have minus 4 root 3 times by 13. And that will give us minus 52 root 3, which is what we expect because we want the root 3 term to cancel off. And then lastly, we're going to have minus 4 root 3 times by plus 4 root 3. So we've got a minus times a plus, which is a minus, 4 times by 4, which is 16, and root 3 times root 3 is 3. Okay, so then we can carry on. The numerator will just keep as it is. The denominator, we're going to have 169, the 52 root 3 minus 52 root 3, that's going to cancel off. And then 16 times by 3 is 48. So we have 169 minus 48, which is 121. So in the end, our final answer should be 11x squared bracket 13 plus 4 root 3 all divided by 121. Okay, so here we have question 3. We're asked to solve an inequality, but the inequality involves the modulus symbols. So the best way to deal with the modulus symbols is just to square both sides. So what we've got here is 5x plus 4 all squared is less than or equal to 2x minus 3 all squared. So we've got to expand the brackets on both sides. So 5x times by 5x is 25x squared. And then 5x times by 4 is 20x. We've got two of them, so that's 40x. And then we've got 4 times by 4, which is 16. On the right-hand side, 2x times by 2x is 4x squared. 2x times by negative 3 is minus 6x. We've got to double it, so it's minus 12x. And minus 3 times minus 3 is positive 9. Now then, what we need to do is we need to move everything on the right-hand side to the left so that we get one quadratic. So we're going to subtract 4x squared from both sides. So we're going to get 21x squared. And then we're going to add 12x to both sides. So we get 52x. And we're going to subtract 9 from both sides so that we get 7. Now, we probably want to try to factorize this if we can. And we've got 21x squared here. So 21 factors to give 7 and 3. So we're going to try putting 7x and 3x there. And then remember that the numbers that we put here are going to have to multiply together to give 7. And they're going to have to combine in such a way that we're going to get plus 52x. Well, if we just think about it a little bit, this one here, if this is plus 7 and this is plus 3, then everything should work out fine. And plus 1, beg your pardon. Everything should work out fine. The reason for that, well, we get 1 times by 7 is equal to 7. We're going to get 7x times by 7x, which is 49x. And then 1 times by 3x is 3x. So 49x plus 3x is 52x. Okay then, so if we were trying to find the x-intercept of this quadratic, our x-intercepts would be minus 1 upon 7, which would be from this thing here, and then also minus 7 upon 3, which would be from this thing here. Okay, now often what happens at this point is that students sort of just give up and they guess what the range of x's will be. Okay, but what we're looking for is where this particular quadratic is less than or equal to 0. So I think the best thing to do is actually just to draw the quadratic. Okay, so if I draw out the quadratic, I'm going to get something that looks kind of like this. Okay, here's the quadratic, and the x-intercepts are going to be minus a seventh and minus 7 upon 3. And so our curve is going to look something like this. Sorry, that's a bit rough. Okay. And so then we've got to ask, well, where is that quadratic less than 0? In other words, where are the y coordinates less than 0? The y coordinates are less than 0 in this region here, right? That's where the quadratic is less than 0. So then we've got to ask the question, well, what values of x give us that region? Well, everything from here all the way up to here. So in other words, our solution is x must be greater than or equal to minus 7 upon 3 and less than or equal to minus 1 upon 7. Okay, I strongly recommend that you get in the habit of drawing graphs as much as possible because it helps you to interpret and understand the question. You want to avoid at all possible costs, I think, guessing your answer. Okay. Okay, next question. So this is question 4, which is a trigonometric identity question and also an integration. We want to show that this expression here, first of all, is equal to a sine bx, where a and b are integers, and hence we want to integrate y between 0 and pi by 5. Okay, well, on the cover of your exam paper, you're actually given some of the identities, so you can reference them there, but the identity that I think will be helpful is sec squared theta is identically equal to 1 plus tan squared theta. Okay, so what we can do is we can take the sec squared 5x in your question and replace it with 1 plus tan squared 5x minus tan squared 5x all over cosec 5x. And hopefully what you can see there is that the tan squared 5x minus tan squared 5x, that cancels off. Okay, now then, what we're left with is 1 divided by cosec 5x. Now at this point, what you need to know is you need to know the definition of cosec. Okay, so cosec theta is equal to 1 upon sine theta. Now, if you are struggling to remember cosec, sec, and cot, the trick is always to look at the third letter, right? Third letter, 1, 2, 3. The third letter is S. So this is 1 divided by sine. Sec, the third letter is C, so it's 1 divided by cos, and cot, the third letter is T, so it's 1 divided by tan. So if cosec is 1 divided by sine, that means that 1 divided by cosec is equal to sine. So we can replace this 1 divided by cosec here with sine 5x. Okay, so we've already done the first part of our question. So in this particular case, A is equal to 1 and B is equal to 5. Okay. Second part of the question is we want to integrate y between 0 and pi by 5. Okay, so in other words, we are integrating sine 5x dx between 0 and pi by 5. Now, sine integrates to give negative cos, so we're going to get negative cos 5x. But then you need to remember the rule that you've got to take the coefficient of the x here, which is 5, and then divide by 5. Okay. The reason for that is you are in effect reversing the chain rule when you are integrating there. Okay. So now we've got to apply the bounds between pi by 5 and 0. So we substitute in the upper bound, which is pi by 5. So we're going to get minus a fifth cosine 5 times by pi by 5, which is pi, minus when we substitute in 0. Now there's a massive danger here, which is most people think that if you substitute 0 into your integral here, it's going to be equal to 0, but that is not the case. The reason for that is that the cosine of 0 is actually equal to 1. So you need to be super careful when you're doing this type of question. So here we've got minus a fifth cos 0. Okay. All right then, cosine pi is negative 1. So here what we've got is minus a fifth times by negative 1 minus a fifth, and the cosine of 0, as I just said, is 1. So this simplifies to give minus a fifth times negative 1 is a fifth minus a fifth, so that's plus a fifth. And a fifth plus a fifth is, oh, beg your pardon, is 2/5. Okay. Okay, question 5 next. This is a factor theorem, remainder theorem question. So the first part is we've got to show that x minus 1 is a factor of this cubic expression here. Well, it's probably helpful that we remind ourselves what the factor theorem is. The factor theorem states that if x minus a is a factor, then that means that x equals a is a root, right? And vice versa. If a is a root, then x minus a is a factor. That is something that you really need to remember and also to understand, okay? So in this particular case, what we've got is we're told that x minus 1 is a factor. Therefore, we know that x equals 1 is a root. Now, how can we verify that it's a root? Well, we substitute x is equal to 1 into the equation, and what we should get is 0. In other words, we expect that f of 1 will be equal to 0. Well, let's just try that out. We're going to get 1 cubed minus 2 times by 1 squared minus 19 times by 1 plus 20. 1 cubed is 1. 1 squared is 1 times by 2 is 2. 19 times by 1 is minus 19 plus 20. Hopefully you can see we've got 1 minus 2 is minus 1, minus 19 is minus 20, plus 20 is 0, right? So we have shown that since 1 is a root, that x minus 1 is a factor, okay? All right, next part. B is we want to write this cubic as a product of its linear factors. There are a couple of ways you could do this. You could try to find the other roots. And the way you do that is you would look at the factors of 20 and substitute them in here. But what I'm going to do is I'm going to do a polynomial division. Okay, so we're going to take the cubic equation x cubed minus 2x squared minus 19x plus 20. And we are going to divide this whole thing by x minus 1. Okay. All right, how do we do this? We take our leading term, which is x cubed, and we divide it by x. X cubed divided by x is x squared. We then take this x squared and we multiply it by the divisor here. So if we do that, x squared times by x is x cubed. X squared times by negative 1 is minus x squared. After this point, we are going to subtract this off from this expression here. So x cubed minus x cubed is 0, which is what we want. Now we've got to be careful. Minus 2x squared minus x squared, which means we're actually going to be adding x squared, is equal to negative x squared there. You need to be super careful there. When you've got a minus, what you're actually doing is you're adding. Okay, now this is our new leading term. So we're going to take the negative x squared divided by x, which gives us negative x. And then we take the negative x and we multiply it by this. So negative x times by x is minus x squared. Negative x times by negative 1 is positive x. And we're going to do the same thing. We are going to subtract this off. So minus x squared minus x squared is 0. Then minus 19x minus x is minus 20x. So we get minus 20x plus 20. And then our minus 20x is our new leading term. We're going to divide that by x, which gives us minus 20. And then we're going to take the negative 20 and multiply it by x minus 1. And that's going to give us minus 20x plus 20. And then if we subtract that off, we're going to get 0, which shows that we have actually done our division properly. And so we can now rewrite our polynomial f of x as x minus 1 times by this thing here, right? So it's going to be x squared minus x minus 20. And if that's the case, we can probably factorize that quadratic to give x minus 5 and x plus 4. So there are our linear factors, x minus 1, x minus 5, x plus 4. And so we have written f of x in terms of the linear factors. And of course, we could also say, even though it's not asked in this question, that the roots must be x is equal to 1, x is equal to 5, and x is equal to negative 4 as well. Okay, then last part of this question is part C. We want to find the exact solution to this particular equation. Well, you want to notice that really this equation is closely related to the one that was above it. I'm just going to try to illustrate that. I'm going to rewrite this as e to the y to the power of 3, right? So instead of e to the power of 3y, I've split that up into e to the y to the power of 3. I'm going to do the same thing with this expression. So this is minus 2e to the y squared minus 19 times by e to the y plus 20. And this is the same thing as the cubic that we had before, except in this case, x has been replaced with e to the y. Okay, so our solutions for x above, the roots that we got, which were 1, 5, and negative 4, will tell us what our e to the y is. So e to the y will either be 1, or e to the y will be equal to 5, or e to the y is equal to negative 4. Okay, so if I just go up, just double check that, yeah. Well then all we got to do is we've got to apply natural logs. Y will equal to the natural log of 1. Well, that's going to be 0. Or y is equal to the natural log of 5. And in this particular case, there is no value of y that such that e to the y is negative 4. So therefore there is no solution here. Okay, so our two solutions are going to be 0 and the natural log of 5. Okay, so here we've got question 6, which is a geometric progression question. And we're told the geometric progression has a first term of 64 and a common ratio of 0.5. So I think the best thing to do first is to identify that. A is equal to 64 and R is equal to 0.5 or a half, because we're going to use those in our formulas. Well, the first part is we are to find the 10th term. So that's U10, and I think the formulas are actually on the formula sheet, but they are A times by R to the power of 10 minus 1, which is 9. Okay, there's a common error here. A lot of students seem to think that this is AR to the power of 9. So in other words, the A is also included in the power of 9, but that is wrong. So you need to make sure that you avoid making that error. It's only the common ratio that is raised to the power. Okay, next part, let's fill in the blanks here. So A is 64, and we're multiplying by a half to the power of 9. We can simplify this a little bit because 64 is a power of 2. It is 2 to the power of 6. So we're going to have 2 to the power of 6 divided by 2 to the power of 9, which is going to be equal to 1 upon 2 to the power of 3, and that will be equal to 1 upon 8. Okay? All right, part 2, we want to find the sum of the first 10 terms. So we need to use the formula for the sum of the first 10 terms. And the sum of the first n terms is a bracket 1 minus r to the power of n all over 1 minus r. So if we substitute in, we're going to have 64 times by 1 minus a half to the power of 10 all over 1 minus a half. And so we need to simplify this a little bit. We're going to get 64 bracket 1 minus. Now 2 to the power of 10 is the same thing as 1024. And on the denominator, we are going to have 1 minus a half, which is just a half. Well, let's try to simplify this a little bit. Firstly, if we're dividing by a half, that's the same thing as timesing by 2. So we're going to have 2 times by 64 times by this fraction here. And this fraction can be simplified to give us 1023 divided by 1024. And so we can hopefully now cancel things off. So we can use a calculator here. I think 2 times by 64 times by 1023 equals divided by 1024 is going to give us 1023 all over 8. And if we were to write that in decimals, that'd be 127.875, and that would be our answer. Okay, so then part 3 of this geometric progression question, we're now asked to find the sum to infinity. So we just got to use the formula for the sum to infinity, which is a over 1 minus r. So we're going to substitute in our values. We're going to get 64 divided by 1 minus a half. 1 minus a half is a half. So we've got 64 divided by a half. Dividing by a half is the same thing as timesing by 2. So that's equal to 128. Okay, then part B of this question is now with an arithmetic progression. And so really what we need to do is we need to reference the formulas. So the nth term of an arithmetic progression is a plus n minus 1 times by d. And the sum of the first n terms is n upon 2, big bracket 2a plus n minus 1d. So what we're going to be doing is we're going to be using these expressions quite a lot. So first of all, we want to use this equation here. We've got S20 minus 400 is equal to 2 times by S10. Well, let's just write this out. We've got to write out what S20 is. And S20 is going to be 20 upon 2, bracket 2a plus 20 minus 1, which is 19, times by d. So that's minus 400 is equal to 2 times by S10. And what's S10? Well, it's again, we're going to be using this summation formula, but in this case where n is equal to 10. So we're going to get 10 upon 2 bracket 2a plus 10 minus 1, which is 9, times by d. And so what we should do is we should expand this, I think. So 20 upon 2 is 10. So we're going to get 10 times by whatever's in this bracket, which is 20a plus 190d minus 400 is equal to 10, because the 2's are going to cancel off, times by 2a plus 9d. So 10 times by 2a is 20a plus 10 times by 9d, which is 90d. So we can simplify this. Firstly, we can subtract off the 20a from both sides. So that cancels and that cancels. And then we're going to have subtracting 90d from both sides. So I'm going to be left with 100d on the left-hand side. I'm going to add 400 to both sides. And that means that d in this case is equal to 4. Okay, so we found out what d is using the first expression. Next, what we've got to do is we've got to use this expression here. If the ratio of the first term to the sixth term is 1 to 5, what that means is that the sixth term is 5 times the first term. So we can rewrite this simply to say the sixth term is equal to 5 times by the first term. And the formula for the sixth term is a plus 5d. And the formula for the first term is a plus 0d. And so we can just expand this to have a plus 5d is equal to 5a. So 5d is equal to 4a. And now we can use our result from earlier. D is equal to 4. So 5 times by 4 is 20. And therefore a is equal to 5, right? So now we know that our arithmetic progression, the first term a is 5, the common difference is 4. And what we're asked to do is we're asked to find the sum of the first 3 terms. So the sum of the first 3 terms, which is S3, will be equal to 3 upon 2 plus 2a plus 3 minus 1, which is 2, times by d. And so we're going to have 3 upon 2, 2 times by a, which is 10, plus 2 times by d, which is going to be 8. So we're going to have 3 upon 2 times by 18. So we divide 18 by 2, we get 9, and 9 times by 3 is 27. So the sum of the first 3 terms should be 27. Okay, next question here, question 7. We've got the variables x and y are related such that we've got this expression here. Use differentiation to find the approximate change in y as x increases from this to this. Okay, this is an approximate change question. It's good sometimes to categorize questions. And you should know that an approximate change question is going to use this relationship that delta y divided by delta x is approximately equal to dy dx, where dy dx is the gradient of the tangent. So in order to do this question first, we need to differentiate this expression here. Now this expression here is one function divided by another function, which means we need to use the quotient rule. The quotient rule, for those of you who may not remember, is y prime is equal to v times by du dx minus u times by dv dx all over v squared. So that's what we've got to do. We've got to identify what u is. So u is equal to 1 plus cos x squared. There's a reason I'm going to write it like that. And v is equal to tan x. Now we need to differentiate both these. So u prime, if I differentiate 1, I get 0. If I differentiate the cos x squared, what we've really got is we've got a function inside another function. We've got cos x inside the function x squared. So when we've got that situation, what we've got to do is we've got to do the chain rule, which is we've got to differentiate the big function first. So we differentiate the bracket, which will give us 2 cos x to the power of 1. So we've done that. Then we've got to look on the inside to the function inside there, which in this case is cos x, we've got to differentiate that, which will give us minus sine x, and multiply through. Next, we differentiate v. If we differentiate tan x, we get sec squared x. Okay, so now what we've got to do is we've got to apply this to the quotient rule, which I stated above. So we're going to have v, which is tan x, times by du dx, which is minus 2 cos x times by sine x, minus u dv, which is 1 plus cos x all squared, times by sec squared x. And this is all divided through by v squared, okay, which is going to be tan squared x. Now what we've got to do is we've got to find the approximate change as x increases from pi by 4 to pi by 4 plus h. In other words, our starting point is when x is pi by 4. So we want to find the gradient when x is pi by 4. What that means is we don't have to simplify this expression here. All we've got to do is we've got to substitute in pi by 4. Now, if we do that, it's helpful to know that pi by 4 is a critical angle. So we can say that sine pi by 4 is equal to root 2 upon 2, and cos pi by 4 is equal to root 2 upon 2, and tan pi by 4 is equal to 1. So if we substitute that into here, we're going to get that y prime is equal to tan pi by 4, which is 1, minus 2 times by cos pi by 4, which is root 2 upon 2, times by sine pi by 4, which is root 2 upon 2, minus 1 plus cos pi by 4, which is root 2 upon 2. In this case, we're squaring it. And then sec squared pi by 4. Well, sec is 1 divided by cos. So what we're going to get is 1 over root 2 upon 2 all squared. Okay? And then this is going to be divided through by tan squared. Well, tan pi by 4 is going to be 1, so 1 squared is 1. Well, let's try to simplify this. I know this looks absolutely horrible, but it should simplify quite nicely. Here we've got root 2 times by root 2, which is 2. We times by 2 again, which is going to give us 4. And we're dividing by 4 there, so we're going to get 1. So what we're left here is with negative 1. Then if we expand this bracket here, root 2 upon 2 squared, well, I'm going to get 2 divided by 4, and 2 divided by 4 is a half. So what I've got here is 1 plus a half. And then this thing here, root 2 upon 2 squared again is going to be 2 upon 4, which is a half. So we've got 1 divided by a half, and 1 divided by a half is 2. So now what I can do is I can expand this and simplify. So I'm going to get minus 1, I'm going to expand that bracket by 2, so minus 2 minus 1. And minus 2 minus 1 is minus 3, minus 1 is minus 4. So our gradient is minus 4. So we can go all the way back to our beginning, where we say that delta y over delta x is approximately equal to dy dx. And so therefore delta y is approximately equal to dy dx times by delta x. Now in this case, what is our approximate change in x? If we go and look at our question, our approximate change in x is just called h. That is the small increase in x. What is our gradient? Our gradient is what we calculated. It's negative 4. So we substitute that in. Our dy dx is negative 4. Our delta x is h. And so the approximate change in y is 4h. Okay, that's our answer. Okay, so here we've got part B. We are given that y is equal to 1 over x minus 3 to the power of 3. And we've got to show that this thing can be rewritten as this thing here. Now, it looks very complicated, but actually really all we've got to do is we've got to differentiate our expression twice and then substitute it in. So that's what we've got to do. Now, if we've got an expression like this, the way we're going to be able to differentiate it is first we have to write it in indices form. That is, we've got to use the following rule, that a to the power of minus n is equal to 1 over a to the n. So we're going to rewrite our expression as y equals x minus 3 to the power of negative 3, right? Because if we write it in indices form, we're going to be able to differentiate in the standard way, which is to take this power, bring it down to the front. So we're going to get negative 3 x minus 3. And we're going to take the power and we're going to subtract 1 from it. So minus 3 minus 1 is minus 4. And then lastly, what we've got here is actually a chain rule. So we need to look inside our bracket. And if we differentiate that, we get 1. And so we multiply through by 1. Now, of course, in this case, that's not actually going to change anything, but it's very helpful for you to be in the habit of doing that because let's say, for example, inside the bracket was 2x minus 3. Well, then you'd have to multiply by 2 here, and that would change things. Okay, so we've done that once. We need to differentiate again. So in the same way, we take the power, negative 4, we bring it to the front. So negative 4 times negative 3 is positive 12. And we're going to get x minus 3. We subtract 1 from the power to get negative 5. And again, we differentiate inside the bracket. We get 1. We multiply through by 1. Now then, we convert into the indices form when we want to differentiate, because we really need it in the form where we've got a power here that we can bring down to the front and so forth. But once we've actually differentiated, we want to convert back to something that looks like this, because that's going to make it easier for us to manipulate. So now what we're going to do is we're going to rewrite this as y equals 1 upon x minus 3 cubed. We're going to rewrite y prime as minus 3 over x minus 3 to the power of 4. And we're going to rewrite y double prime as 12 over x minus 3 to the power of 5. Now, if you're not sure about that, let me just try to explain it a little bit. I'll use the y double prime. What we're really saying here is that we have got 12 times by 1 over x minus 3 to the power of 5. Right, that's what we're saying. Right, we've got this thing times by this thing here. Okay, and if we've got 12 times by 1 over x minus 3 to the power of 5, then we've got 12 upon 1 times by 1 upon x minus 3 to the power of 5, which is the same as 12 over x minus 3 to the power of 5. So I think sometimes people get a little bit confused there. I hope that that was helpful if you struggle with that. Okay, so now what we've got to do is we've got to substitute in. So we have got to write y, which is 1 upon x minus 3 cubed, minus dy dx, which is minus 3 over x minus 3 to the power of 4, minus a third of d2y dx squared, which is 12 over x minus 3 to the power of 5. Okay, now then, what's this thing equal to? Well, really what we need to do is we need to give everything here the same denominator, right? So the denominator we need to give it is got to be x minus 3 to the power of 5. So for this expression here, I need to multiply top and bottom by x minus 3 squared. So if I do that, I'm going to get x minus 3 squared over x minus 3 to the power of 5. Here what I've got is minus 3, so that's plus 3. And if I want to have a denominator of x minus 3 to the power of 5, I need to multiply top and bottom by x minus 3. And then lastly, with this expression, I don't need to do anything multiplying top and bottom, but I can multiply the minus a third with 12, And timesing by a third with 12 is the same as dividing 12 by 3. So I'm going to get minus 4 over x minus 3 to the power of 5. And so now I can rewrite this all on one denominator. So the denominator I'm going to get here is x minus 3 to the power of 5. And now all that remains for me to do is basically just to expand this thing. So I've got to expand x minus 3 squared. So that will give me x squared minus 6x plus 9. I'll expand the second expression to get 3x minus 9. And I've got a minus 4 at the end. So now all I've got to do is I've got to collect the terms. So I'm going to get x squared minus 6x plus 3x is minus 3x. 9 minus 9 is 0 minus 4. All divided through by x minus 3 to the power of 5. Okay, and let's just see what we're supposed to get for our answer. Yeah, we're supposed to factorize, aren't we? Up here, they want us to factorize like that. Well, that's going to be fairly straightforward. We've got a quadratic here. Okay, are we able to factorize that? Well, yes, we're looking for two numbers that multiply together to give negative 4, and that will add up to give negative 3. Well, those two answers will be negative 4 and positive 1. Okay, so our final answer is going to be x minus 4 times by x plus 1 over x minus 3 to the power of 5. And if we just double check that, yep, that is our answer. Okay, so that's part B. Okay, question 8, which is a functions question. We're told here that we've got a function which is 5 minus 2e to the negative x, which is defined for a domain of x is greater than or equal to 0. And first we'll have to find the domain of f inverse. Now it's important to realize that finding the domain of f inverse is the same thing as finding the range of f. So in other words, we want to find the range of this function here, which is all of the possible y values. Now, in order to do that, I suggest that we just sketch this graph as being the easiest thing. Now, if you've got an exponential graph, really there are a couple of things you want to do. The first thing you want to do is to find the y-intercept. Okay, the y-intercept is when x is equal to 0. So if we substitute x is 0 into our function, we will get y is equal to 5 minus 2 e to the power of 0, and e to the power of 0 is 1. So we get 5 minus 2, which is 3. So that's our y-intercept. The second thing that I suggest you do is you find the asymptote. Okay, now that's really asking the question, what will happen as x tends to either positive infinity or negative infinity? Well, in this case, because we've got an e to the minus x graph, then we can say that as x tends to positive infinity, e to the negative x is going to tend towards 0. And if that's the case, then we will be left with y is equal to 5 minus 2 times by 0, which is just equal to 5. So if we take these two bits of information, we should be able to draw our graph reasonably well. So let's draw our y-axis and our x-axis. Okay, now what I'm trying to say is we've got a couple of key points to consider. Sorry, beg your pardon, that should be a y. The first point that we want to consider is the y-intercept, which is where x is equal to 3. So 1, 2, 3, 4, 5. So this is going to be our x-intercept there. Sorry, y-intercept, beg your pardon. And our asymptote is going to be when y is equal to 5. That's going to be that line there. And we know that as x tends to positive infinity, the graph is going to tend towards the asymptote. So in other words, we're going to be on that side. So our graph is going to look something like this. Okay, now then, we've got to be super careful here because actually in this question, the domain of our function f is when x is greater than 0. Okay, which means that this part of the graph is not included. So actually what I need to do is I need to get rid of this. I get rid of that. Okay, all the way up to there. Okay, And so now what I've done is I've sketched the function f. So I should be able to find the range. The range is all the sets of the y values that this function takes, which is everything between here and here. So I can say actually the range of f is as follows. F is greater than or equal to 3, and it is less than 5. It's not less than or equal to because it's an asymptote, so it can never be equal to, but it's less than or equal to. And therefore, we can say that the domain of f inverse is x is greater than or equal to 3 and less than 5. Now, that seems like a lot of work for 2 marks. There may be ways of doing it shorter and faster, but I try to encourage students as much as possible to make sure you understand fully what's going on. And in this case, I really think you need to draw a graph in order to understand that. So please try not to take a shortcut, even if you think it's going to be a faster way of getting the answer. You always want to aim for understanding. Okay, so part 2 of this question, we are supposed to solve f of f inverse x is equal to the square root of 5x minus 4. Now, this actually makes my point from earlier, which is if we understand what's going on with functions, then this question is actually really quite simple. But it's going to throw a lot of people off because this looks very, very strange. But we've got to ask, what does this mean? This is the same thing as f of f inverse x. This is a composite function. In other words, what we're doing is we're taking the output of our inverse function and we're putting it into our original function. Now, I think this is probably best explained with the diagram. Let's try to understand what's going on here. Let's imagine that we've got some function f. What does that function do? It takes an input x and it gives us an output y. Now, what is the inverse function supposed to do? It is supposed to take that output y as a new input and return us back to the original value of x. In other words, let's say that we were to put 3 in to our original function and we got an output of 7. What the inverse function should do is it should take that value of 7 and return us back to the original input of 3. So in other words, what this means is, in our function, we have taken an input to the inverse function to get an output. We've put that output back into the original function, and so it should return us back to the start. What that means is that this notation here is just going to return us to x, right? Because we take x, put it in as the input to our inverse function, take the output of that, put it into our original function, means we should get back to where we started, which is just x. So once we understand that, really what we've been asked to solve is x is equal to the square root of 5x minus 4. And this is going to give us a quadratic. Square both sides. And so we get x squared minus 5x plus 4. 5x, beg your pardon. And so that will factorize to give x minus 4 and x minus 1. And that will solve to give x is equal to 1 or x is equal to 4. Now we do just need to be a little bit careful here because we need to remember that this f is actually defined by this thing up here. And we were told that our x values can only, for the inverse function, can only be between 3 and 5, right? So that the domain of the inverse function is everything between 3 and 5. Well, that means that this value here, x is equal to 1, must be excluded. That is incredibly subtle, and that's very sneaky, and that's going to catch out most people. But what we're really saying there is that x is equal to 1 cannot be an input to f inverse. The reason it cannot be an input to f inverse is because it is not in the domain of f inverse, which was what we found in our previous question. Okay, that's all very hard, but again, this is really testing students whether or not they understand the definitions, the notation, and the core ideas. Okay, so here we are in part 3. On the axis, we are supposed to sketch the graph of f of x, which actually I already did in part 1 of this question because it helped me to do that part. And then we want to use that to sketch f inverse. We want to show clearly the positions of any points where the graph meets the coordinate axis and the positions of any asymptotes. Well, if we just go back to what I said earlier, right, this was the graph of f. And so I'm just going to repeat that over here. So we said that our axes would look like this. Okay, and that. Ooh. And we would have an asymptote at y is equal to 5, beg your pardon. So I'll draw that on. And it will cross the y-axis at y is equal to 3. And so the graph of f looks something like this. Okay, so that there is the graph of f. Now then, if we know anything about inverse functions, is inverse functions are reflections in the line y equals x. So I'm going to sketch on the line y equals x like that. Okay, something like that. And so my inverse function, what's it going to do? Well, this point here, which is the y coordinate of 3, is going to be reflected to an x coordinate of 3. So let's say that's there. Okay, so that's the x coordinate 3. And this asymptote here, which is y is equal to 5, that's going to be reflected to an x asymptote of x is equal to 5. So I'm going to sketch that like that. I hope that works. Something like that. Okay. And so my graph is going to be a reflection here in the line y equals x, which is the green line. It's a little bit hard to do this with a tablet, by the way, so I hope you'll forgive that. What should happen is that those lines should intersect at the green line, the line y equals x. But that will be roughly the answer there, which is f inverse. Okay? Okay, so the last part of this question, we've got a new function, which is g, which is defined for this domain by the expression 3 over 1 minus x. We want to find and simplify an expression for f inverse of g of x. So we've got another composite function here, and this includes f inverse. So I think the first thing we want to do is want to find out what the inverse function is. Now we were told the original function, f of x, was equal to 5 minus 2e to the minus x. Now, if we want to find the inverse function of that, really what we're being asked to do is to rearrange the function to make x the subject. So the way I'm going to do that is I'm going to subtract 5 from both sides. And then I'm going to divide both sides by negative 2. So I get e to the minus x is equal to 5 minus y upon 2. And then I'm going to apply the logarithmic form. So negative x is going to equal to the natural log of 5 minus y upon 2. And so x is going to equal to minus ln 5 minus y upon 2. And I suppose what I could do is I could say that x is equal to ln 5 minus y upon 2 to the power of negative 1, which is I'm using the log rule to bring the negative 1 here as a coefficient up as a power. And the power of negative 1 is the same as 1 divided by, so I could rewrite this as the natural log of 2 over 5 minus y. And if that's the case, then I could say that my inverse function, f inverse of x, means I just replace the y with an x. So I get ln of 2 over 5 minus x. That's my inverse function there. Now, what's the question asking me? Is asking me to find the composite function f inverse of g of x. So this means I'm finding f inverse of g of x, and g of x is 3 over 1 minus x. So I need to input 3 over 1 minus x into this function. So I want to find f inverse of 3 over 1 minus x. So I'm going to substitute that in. So I'm going to get the natural log of 2 over 5 minus 3 over 1 minus x. And that's not a very pretty looking expression, but I think probably what I will do is I'll multiply the top and bottom of the fraction by 1 minus x. So on the numerator, I will get 2 bracket 1 minus x over 5 bracket 1 minus x minus 3. And then I can simplify this to get the natural log of 2 bracket 1 minus x over, well, here I'm going to get 5 minus 3, which is 2, minus 5x. Okay, now let's see what we were asked to do, just to check. We want to find and simplify an expression. Well, I think that is probably about as simplified as we can get. Okay, here we've got a circular measure question. We've got two sectors, AOB and COD, which have the same center O, and they've got the same angle, which is 3 pi upon 8. We're told that the length of OC is 6.5. Now, I think it's very helpful to label very clearly on the diagram. So this length here, we're told, is 6.5. That's that. Okay. And it is given that OAC and OBD are straight lines and that the ratio of the length OA to OC is 4 to 5. What does that mean? Well, it means that OA is going to be equal to 4/5 of OC. Okay, so immediately we can calculate that because we know that the length of OC is 6.5. So we do 4/5 times by 6.5. And we can put that into our calculator. So we get 6.5 times by 4 divided by 5, which is 26 upon 5, or 5.2. So this here is 5.2. Okay, we want to find the perimeter of the shaded region. So you can first label that length as 5.2. How are we going to find the perimeter of the shaded region? Well, we need to find this length here, BD, which is the same as AC. And we also want to find this arc length here and this arc length here. Well, okay, the length AC is going to be quite easy because that's going to be our 6.5 minus 5.2. So AC is going to be this length here minus this length here. Okay, 6.5 minus 5.2. And that's going to be equal to 1.3. Okay, then the next thing is we want to find the arc lengths A, B, and CD. Well, the formula for the arc length is S is equal to R theta. So we're just going to apply that in both cases. So AB is going to equal the radius 5.2 times by the angle 3 pi upon 8. Okay, and we'll multiply that out as well. So we're going to get 5.2 times by 3 divided by 8. That's 39 upon 20 pi. Okay, and then we can do the same thing for CD. CD will be equal to the radius, which is 6.5, times by the angle, which is 3 pi upon 8. And if we were to multiply that out, so 6.5 times by 3 divided by 8 is 39 upon 16 pi. Okay. That's that arc length there. Well, then if we want to find the perimeter of the shaded region, perimeter, all we've got to do is we've got to add up those things. So we've got to add up our arc length AB, which is 39 upon 20 pi, plus the arc length CD, which is 39 upon 16 pi, plus 1.3 times by 2. I suggest you write that out, by the way, because often there is a mark for indicating your method. So 39 upon 20 pi plus 39 upon 16 pi plus 2 lots of 1.3. And if you punch that all into a calculator, the answer that you should get would be 16.4. Okay, so 16.4 is your final answer. Okay. Okay, so this is the second part of our circular measure question. This is a difficult question. I haven't seen one quite like this in previous papers. And consequently, I think that a lot of students will get intimidated by this and may not even attempt it. However, I've got 2 points before we start to find the solution, which is this. Firstly, with any difficult question, what you really want to do is to break it down into smaller, more manageable questions. Okay, so the first thing to state is if we're trying to find the area of the shaded region here, then what we're really doing is we're finding the difference between the area of the circle and the area of the sector. So I think it's always helpful just to write that down first, because the area of the circle should be quite easy. That's pi r squared, and the radius of the circle is a, so we've got pi a squared. And then the area of the sector is given by the formula that we should know, which is a half r squared theta. So we're going to get a half. The radius of our sector is y in this case, right? That's that length here. So a half y squared theta, and the theta is going to be whatever this angle is, this angle here, which temporarily I'll just call theta. Okay, so then what have we got? Well, we hopefully would have got some marks just for writing down those two things. And if you really were not sure what to do after that point, you should also write down that the area of the shaded is the area of the circle minus the area of the sector, because you might get a method mark for that. But let's say we want to carry on with the problem. What we really need to do is we want to find out what y squared is. We want to find out what theta is. Now this brings me on to my second piece of advice, right? So first is to break down a hard question into smaller, more manageable questions. My second piece of advice is that when you've got a question like this, a good clear diagram really, really helps. So what we've got is a circle of radius a. And we know that because the distance from here to this point here is a. Well, if that's the case, then the distance from here to here is also going to be a, and the distance from here to here is also going to be a, right? Because it's the distance from the center of the circle to the edge of the circle. So these distances are all the same. Now, that tells us something very important straight away. It tells us that we have got two identical triangles here and here. Right, two identical triangles, and that these triangles are also isosceles because they've got the same length here and here. That means that we can label this angle here as being phi, and this angle here as being phi, and this angle here as being phi. Okay. The next thing it tells us is if these true triangles are identical is that this length here, which we know is y, must be the same as this length here. That must also be y. Okay, so that's going to help us. The first way it helps us is it tells us that our angle theta is actually equal to 2 phi. Right, so I can rewrite this area of the sector, which was a half y squared theta, as being a half y squared times by 2 phi. So in other words, we've got y squared phi. So we're very close now. The only thing that we've got to deal with is we've got to find an expression for y. Well, there are a couple of ways we could do this. We could use the cosine rule, for example, with one of these triangles here. But I think actually an easy way to do it is to think about making this triangle a little bit smaller. So again, we're going to break a bigger problem down into smaller problems. Beg your pardon. I'm going to split that isosceles triangle into two equal triangles. This triangle here is going to be a right angle triangle. So that means that this length here is a half of y. So what would a half of y be equal to? Well, we could say that the cosine of phi must be equal to the adjacent side, which is a half of y, divided by the hypotenuse, which is a. So I can write that, the half of y divided by a. And so that means if I rearrange, y is going to be equal to 2 times by a times by the cosine of phi. So now I can substitute that into my area of the sector. I can carry on and say, well, the area of the sector must be equal to 2a cosine phi all squared times by phi. And if that's the case, we can do our last step, which is say the area of the shaded is going to equal the area of the circle, which is pi a squared, minus the area of the sector, which we now know is 4a squared times by phi times by the cosine of phi. And perhaps lastly, what we would want to do for the sake of completeness is just to factorize this. So we would get here a squared bracket pi minus 4 phi times by the cosine of phi. Okay, that's our final answer. Now, in the mark scheme, you'll see that there are many, many alternatives to this answer that are all equivalent. They're all the same, right? So it doesn't matter which way you did it, but I think this is the simplest way. So bear in mind, guys, very difficult question. Break it down into smaller questions. You should be able to get some marks, at least for the starting things, but also a good clear diagram, right? Label everything because that will help you to understand what's going on. Okay, so we're in question 10. We've got a particle which has acceleration given by 6t between 0 and 3 seconds and is given by this expression here when t is greater than 3 seconds. We're told that the velocity is 2 when t is equal to 1 and the displacement at that point is negative 4 meters. We want to find the velocity of p when t is equal to 3. Okay, I think it's probably helpful just to recap very quickly how to do this type of question. Basically, we've got displacement, which we label as s. We've got velocity, which we label as v. We've got acceleration, which we label as a. And essentially, if we know the definition of velocity, velocity is the rate of change of displacement. That means that velocity can be written as ds dt. In other words, we differentiate displacement to get velocity. And the same thing is true if we think about acceleration, because the definition of acceleration is the rate of change of our velocity with respect to time. So we can write acceleration as dv dt, which means that if we differentiate velocity, we will get acceleration. Now, if that's true, we can also say the reverse. If we integrate acceleration, we will get velocity. And if we integrate velocity, we will get displacement. So if you understand that, this diagram here, then you should understand most of these questions. In other words, we differentiate to go from displacement to velocity, and we differentiate again to go from velocity to acceleration. And if we want to reverse the process, then we integrate. Okay, so what have we got here in this question? We want to find the velocity when t is equal to 3. Now notice that 3 is kind of the boundary condition for this. Okay, so how are we going to find the velocity? Well, velocity is equal to the integral of acceleration with respect to time. Okay, so how are we going to do this? Well, we are now integrating 6t dt. We integrate 6t, we're going to get 6t squared over 2 plus c, which is a constant. Okay, well, this is where the condition here becomes important, because we're told that when t is equal to 1, the velocity is 2. That means that we are able to substitute those values in order to find out what c is. So let's just do that. Okay, when t is equal to 1, v is equal to 2. That means if we substitute in, we get 2 is equal to 3 times by 1 squared plus c. So c is going to be equal to negative 1. Okay, because we do 2 minus 3. Therefore, the velocity of our function is equal to 3t squared minus 1. Now what we're asked to find is we're asked to find the velocity when t is equal to 3. So we just substitute t is equal to 3. So we now say when t is equal to 3, the velocity is equal to 3 times by 3 squared minus 1. And so 3 squared is 9, times by 3 is 27, minus 1 is 26. So our answer is 26 meters per second. Okay, then part 2 of this question is we're asked to find the displacement of P when t is equal to 3. Well, we just got to go back up to our key point here. How do we find displacement? Displacement can be found by integrating velocity. So we're going to write that statement that displacement is equal to the integral of velocity with respect to time. And what is our velocity given by? Well, if we just go up, our velocity is going to be given by this expression here, 3t squared minus 1. So what we're being asked to do is to integrate 3t squared minus 1 dt. If we do that, we're going to get 3t cubed divided by 3 minus t plus another constant, which in this case I'll call k. So this is t cubed minus t plus k. And again, what we want to do is we want to find out the value of this constant here. How are we going to find that constant? Well, we've got to substitute in. If we go back up the question, we are told that when t is equal to 1, the displacement is negative 4. So we're going to write that down. I come here and say, when t is equal to 1, the displacement is equal to negative 4. So we can substitute that in. Negative 4 is equal to 1 cubed minus 1 plus k. And 1 cubed minus 1 is 0. So k is equal to negative 4. Therefore, our displacement is given by the equation t cubed minus t minus 4. And what we're asked to do is to find the displacement when t is equal to 3. So now we need to substitute t is equal to 3. So we can say when t is equal to 3, the displacement is equal to 3 cubed minus 3 minus 4. 3 cubed is 27, minus 3 is 24, minus 4 is 20. So our displacement is going to be 20 meters. Okay, so last part of this question, we are asked to find an expression for the displacement when t is greater than 0. Now we need to go back up and reference the first part of this question where we are told that the acceleration is equal to 18 e to the power of 3 divided by e to the power of t when t is greater than 3. So we're interested in this one here. Let's go and write that down. So the acceleration A is equal to 18 e to the power of 3 divided by e to the power of t. And I suggest that we rewrite that as 18 e to the power of 3 minus t using our indices rule. If you're not sure about the indices rule is that if we've got a to the power of x divided by a to the power of y, that's equal to a to the power of x minus y. I subtract the powers. Okay, well now we need to find displacement, which means we've got to integrate once to get the velocity and then integrate again. So velocity is the integral of the acceleration with respect to time. So we're integrating this expression here. And if we integrate this, then the exponential remains unchanged. But then we differentiate the power of the exponential. We differentiate this, which gives us negative 1. And so we divide by negative 1. And we get plus some constant. I'll use c. Okay? That means that if we just rearrange this a little bit, we get minus 18 e to the power of 3 minus t plus c. Now, earlier on in the question, we found out that when the time is equal to 0, when the time is equal to 3, beg your pardon, the velocity is equal to 26. So we can apply this condition to here. We can say that when t is equal to 3, the velocity is equal to 26. So we substitute those values in. 26 is equal to negative 18 e to the power of 0, because 3 minus 3 is 0, plus c. And e to the power of 0 is 1, so 26 is equal to negative 18, beg your pardon, plus c. And so c is equal to 26 plus 18, which is 44. That means that we can state, better use this side here, we can state that the velocity is equal to minus 18 e to the power of 3 minus t plus 44. So now if we want to find the displacement is the integral of velocity. So we're integrating negative 18 e to the power of 3 minus t plus 44 dt. And if we integrate that, we're going to integrate in effectively the same way as before, which means we've got to divide again by negative 1. We integrate 44, we get 44t, and we got another constant here, which I'll call d. Again, we can use our answer from the previous question because we're told that when t is equal to 3, we found that the displacement is 20 meters. So we can apply that condition. When t is equal to 3, s is equal to 20. So if we apply that condition, what we've got is 20 is equal to positive 18 e to the power of 0 plus 44 times by 3 plus d. And if I simplify that, I'm going to get 20 is equal to 18 plus 132 plus d. So 18 plus 132 is going to give us 150. So d there looks like it will be minus 130. Therefore, our displacement is given by 18 e to the power of 3 minus t plus 44t minus 130. And that should be our answer. Okay, so we're on the final question of this paper, question number 11. The normal to the curve y equals sine 4x minus pi at the point A, where the x-coordinate of A is between pi by 2 and pi, meets the y-axis at the point B, find the exact area of the triangle OAB where O is the origin. Now this is a very long, very difficult question, but what we need to do, as with all difficult questions, is to break them down into smaller, simpler questions. Now the first part of this will be to find what this coordinate here is A. Now the first thing to understand is that the y-coordinate of this point is 0. Now what that means is that A is an x-axis intercept of the curve y equals sine 4x minus pi, right? Why is it an x-intercept? Well, because on the x-axis, the y-coordinate is always 0. So if we know that this y-coordinate is 0, we know that this is an x-axis intercept. So what we need to do is we need to substitute y is equal to 0 into our curve. If we do that, we get 0 is equal to sine 4x minus pi. If we know anything about the sine curve, right, if I was to sketch out the sine curve for you like this, very rough and in brief, where is the sine curve equal to 0? The sine curve is equal to 0 here at the point 0, here at the point pi, here at the point 2 pi, and here at the point 3 pi. Okay, so in other words, what we've got here is that 4x minus pi must be equal to either 0 or pi or 2 pi or 3 pi or so on and so forth. Okay, then if we add pi to both sides, we get 4x is equal to pi or 2 pi or 3 pi or 4 pi, right? So what I've done there is I've added pi to 0 to get this. Pi to pi gives me 2 pi. If I add pi to 2 pi, I get 3 pi. And if I add pi to 3 pi, I get 4 pi there. Then if I want to find out what x is, I've got to divide both sides through by 4. So this becomes pi by 4. This becomes pi by 2. This becomes 3 pi by 4. And this becomes pi. Now, if we read our question, we are told that the point A is between pi by 2 and pi, but it doesn't include pi by 2 or pi. So what we've got here is that our answer A must be this one. Okay, so all the other values are excluded. We're not this one or this one. This thing here is our coordinate A. Okay, so A is the point 3 pi by 4, comma 0. Okay, so what we want to do is we want to find the normal at that particular point. So then, now what we want to do is we want to find the equation of a normal. Well, if we want to find the equation of any line, then we need two things. Firstly is we need the coordinate point of the line. Well, we've already got that because that's the point A, which we said is 3 pi upon 4, 0. So that's already done. The second thing we need to do is we need to find the gradient of the line. How do we find the gradient? Well, in this particular case, we need to differentiate first to find the equation of the tangent. So let's differentiate. Y is equal to sine 4x minus pi. If I differentiate that, then what I'm going to get is sine differentiates to give cos. So I get cos 4x minus pi. And if I differentiate the inside of the sine function, if I differentiate this, I get 4. So I multiply through by 4. Okay? So that tells me the gradient of the tangent, and I want to find the gradient of the tangent when x is equal to 3 pi by 4. So the gradient of the tangent, which I'll now call mt, right? But it's the same thing as this. Gradient of the tangent is equal to 4 cosine 4 times by 3 pi upon 4, which is 3 pi, minus pi. So that's the same thing as 4 the cosine of 2 pi. And the cosine of 2 pi is 1. So the gradient of the tangent is 1 times by 4, which is 4. Now that we've got the gradient of the tangent, we can calculate the gradient of the normal. And the way we calculate the gradient of the normal is to use the following expression that the gradient of the tangent times by the gradient of the normal is equal to -1. Because if two gradients are perpendicular, they multiply together to get -1. That means that the gradient of the normal here is -1/4. Okay, so I've got the coordinate of my normal. I've got the gradient of the normal. So now what I can do is I can substitute them in to the formula y minus y1 is equal to mx minus x1, where x1, y1 is my coordinate point. So if I substitute that in, I get y minus 0 is equal to m minus 1/4 x minus x1, which was 3 pi over 4. So if I was to multiply this out, y is equal to minus 1/4 x, and a minus 1/4 times by minus 3 pi by 4 is plus 3 pi upon 16. So that's the equation of my normal. Now let's go back to the question. This normal meets the y-axis at the point B. So what is the point B? It's the y-intercept of this line here. So now what we want to do is we want to find the y-intercept of the normal. And the way we find the y-intercept is we set x equal to 0. So I substitute x equals 0 into here, and I get y is equal to 3 pi upon 16. So what does that mean? That means that my coordinate B is 0, 3 pi upon 16. Well then, if I was just to simply draw out my coordinate frame, then what we're saying is that the coordinate A is the point 3 pi upon 4, 0. So let's put that here, right? This is A, which is 3 pi upon 4. Or rather, A has got x coordinate 3 pi upon 4. That may be the better way of writing it. That's A, x coordinate 3 pi upon 4. And we've got B, which is the coordinate 0, 3 pi upon 16. So the y coordinate is 3 pi upon 16, and this here is the origin. Well, what are we being asked to find? We're being asked to find the area of this triangle here. And the fastest way to find the area of the triangle is to use the formula for the area of a triangle. And the formula for the area of a triangle is a half base times height. So we've got a half the base, which is 3 pi upon 4, times by the height, which is 3 pi upon 16. Right, that's that thing there. So now if we multiply this out, we're going to get 3 pi times by 3 pi, which is 9 pi squared, over 2 times by 4 times by 16. So that is 8 times by 16, which is 128. So the answer should be 9 pi squared over 128. Let me just check that's everything we're asked. Yes, that's everything we're asked.